So, time dilation. So imagine that you're in space and you have a clock and a very fast spaceship kind of just floating there. So you're looking at the clock and you see that it emits a pulse every 1 second. Now you see the pulse every 1 second, as you might imagine, pretty normal. Now say you decide to fly away at 87% the speed of light, which happens to be around 300 millimeters per second, the speed of light in a vacuum. Then you see the pulse every 2 seconds, which is weird. The clock appears to you to be running slower. If the clock was watching you, you would look like you were moving slower, and this is called time dilation. It's all thanks to some crazy dude with lots of hair and no eyes that said, "Z is constant and light is always the same speed." And we kind of believe him. So let's check out an extreme example. These are two twins, exactly 20 years old each. So one decides to fly away in a spaceship. He's traveling 99.5% the speed of light, and he's just gonna take a trip for 1 year his time. So when he takes off, they're both 20 years old. And once the clock in the ship registers 1 year, he will come back to Earth. And you might assume, they'll both be a year older. But that's not true. The twin that took the trip will come back 1 year older, 21, and the twin that stayed behind will be 30, 10 years older. Isn't that ridiculous? And you may be thinking, well, this can't really affect anything. You and me and baseballs all move a lot. Our velocity is a lot less than the speed of light, so could it possibly affect anything that matters? Well, actually, it affects GPS. The satellites move so fast that they're affected by time dilation and have to be adjusted to be slow by 38,500 nanoseconds per day. So it actually does have some measurable effects that we need to account for. And there are actually some exciting implications for if we can ever travel close to the speed of light. We could make trips to stars that are very far away without having it to have to take a lifetime. So if an astronaut needs to go to a star that's 11.4 light years away, and he's traveling, almost the speed of light, if he goes there and back, for everyone on Earth, it'll be 22.8 years later, but he will only have aged 3 years, and only have lost 3 years of his life for the trip. So let's look at one last extreme example. Say you're on Earth and want to time travel forwards. So you take off in a spaceship traveling almost the speed of light, and you just take a trip around space for 5 years, your time. When you get back, it will be 450 years after you left. So by spending 5 years of your life, you will have effectively time traveled forward 450 years. And that is time dilation.